Hi, I'm Nicole Fry from the San Francisco Bay Regional Water Board, and I'm going to walk you through step 4. This step discusses risk evaluation and risk management decisions. Step 4 contains these 4 sections. The first section is a new addition since the 2020 draft. It was added in response to public comments that site-specific information is needed to inform risk management decisions. So this section provides considerations for refining the initial risk assessment with site-specific information to support that final risk management decision. We also decided to separate the future risk discussion into existing building and future building, as you'll see in step 4C and 4D. This was in response to many public comments asking for more information about future buildings and how to manage the risk there. And so hopefully this will highlight where to go for that information. Another big change was that we removed this risk management table in the final draft. This was in response to public concerns that the guidance should not recommend specific response actions based solely on a risk and hazard values, since there are many lines of evidence that go into such risk management decisions. In addition, a lines of evidence attachment was added to the guidance to help describe all of the information that should be considered when making risk management decisions. Ross will be discussing this attachment next. One of the main goals of this guidance is to provide a process for evaluating VI risk. The guidance stresses the need to assess the risk at each building located near site contamination. In the example shown here, there are 7 buildings that each have to be evaluated for VI risk. Steps 1 through 3 discuss the process for initial VI screening, while step 4 discusses how the initial screening assessment can be refined for a building once sufficient site-specific information has been collected. Step 4 does not replace this initial screening. There will be situations where you'll need to make an initial risk management decision using the initial screening evaluation. And then, as more data is collected, step 4 can be used to refine that assessment and make the final risk management decision. Therefore, step 4 is designed to occur after initial screening. There are 2 types of VI risk that we need to assess. First, there's current risk, which considers what people are currently breathing, and current risk is calculated primarily using indoor air data. We also have to assess future VI risk, which considers future changes that could increase vapor intrusion, like changes to the heating, ventilation, and air conditioning operation of a building, remodeling, or potentially new cracks and damage to the building over time. Primarily, future risk is calculated using subsurface VFC concentrations in soil gas or subslab data. This slide provides an overview of the different VI risk assessment refinements. For refining current risk assessments, you can use building-specific exposure parameters based on the current building occupants, and you can use average indoor air vapor-forming chemical concentrations. For refining future risk assessments, you can use average subsurface or soil gas vapor-forming chemical concentrations, and you can use building-specific attenuation factors based on site-specific information about the building. I'm now going to go through an example to explain what we mean by using building-specific exposure parameters to refine current risk assessments. So for initial screening, we typically use a generic indoor air exposure time period, as shown here. So for commercial worker, we assume 8 hours a day, 5 days a week, 250 days a year, up to 25 years of exposure. And so after the initial screening, once we've collected more site-specific information, in this example, we have a storage building where we know the occupants of the building are only expected to be in the building 2 hours a day, 5 days a week, 250 days a year for up to 25 years. And so in step 4, we can use this information to refine that current risk. Now I'm going to go over some of the considerations for averaging sampling data for current or future risk assessments. When we're talking about averaging, we're talking about 95% upper confidence limit on the arithmetic mean. So for this type of calculation, you really do need a sufficient number of sampling events if we're averaging over time, or a sufficient number of sampling locations if we're averaging over space. And just as a reminder, for those initial screening assessments, we're not going to have a sufficient number, so we're going to use the maximum concentration to get that initial screening evaluation. And then as we collect more data, we can use step 4 to refine that risk. I'm now going to go through some of the things that we don't recommend doing when averaging data. So first, we don't recommend averaging sampling events with increasing vapor-forming chemical concentrations. This is particularly important for thinking about future risk. Second, we don't recommend averaging sampling locations over large areas, specifically large areas with different HVAC zones, different multiple exposure areas, hotspots and outliers, and or multiple sampling depths and heights. Third, we don't recommend averaging sampling locations or events if there's a short-term exposure concern, such as TCE above a short-term exposure level. Now I'm going to go through this example, looking at indoor air data and deciding whether we should average this data or not. So here we have a multi-unit building. There's 2 units with 2 exposure areas, 2 different HVAC zones. And in addition, we have higher concentrations on the right unit versus the left unit. And so for this example, it's pretty clear that we don't want to average because we have the different HVAC zones, the different exposure units, and the kind of the hotspot area. Okay, now let's go over how to select a potential future subslab to indoor air attenuation factor that can be used to refine the risk assessment for an existing building. So first, we're going to calculate the empirical subslab to indoor air attenuation factor. We're going to want to use indoor air and subslab data that is paired. And ideally, you're going to want to have enough data collected throughout the building to get a sense of the spatial variability and collected over time to get a sense of temporal variability. And then it's going to be a really site-specific decision whether or not you're going to average the data in any way. But ultimately, you're going to divide the indoor air concentration divided by the subslab soil gas concentration to get that empirical attenuation factor. And for an example, we're just going to use 0.0008 for our empirical attenuation factor. So next, we're going to select a potential future attenuation factor. And so this value needs to be greater than our empirical measured attenuation factor to account for changes to the building over time. And typically, you're going to select this value from a range of values that are observed in an applicable VI database study. And so in this example, we're selecting 0.003 as the potential future attenuation factor. It's the 50th percentile of the US EPA VI database. And you can see that this value is greater than our measured value. Now we're going to go over how to select the potential future soil gas to indoor air attenuation factor. Again, this is for an existing building. So first, we're going to start with our potential future subslab to indoor air attenuation factor. You're either going to select the 0.03 screening attenuation factor or a justified value, as we discussed on the previous slide. And again, we're choosing these values to account for changes to the building over time. And then next, we want to look at the empirical soil gas to subslab attenuation factor. So for initial screening, we assume that there's no attenuation below the building. But as you'll see when you collect the data at your site, you might have some attenuation. And so to get a sense of that, you can calculate the soil gas to subslab attenuation factor by dividing the subslab concentration by the soil gas concentration. And now with these two attenuation factors, you essentially multiply them together and you can get this potential future soil gas to indoor air attenuation factor that accounts for the actual measured attenuation below the building, while also using a conservative subslab to indoor air attenuation factor that is accounting for potential changes to the building over time. Now let's look at using modeling to predict the potential future soil gas to indoor air attenuation factor. You can do this for an existing building where it's infeasible to collect that subslab data, or you can do it at a future building that hasn't been built yet. And so in this modeling, we first want to account for a potential future attenuation factor that accounts for changes to the building. And so one example of how you do this is using US EPA's modeling tool based on Johnson-Ettinger modeling. And in their model, you can input a Q soil over Q building value. And so Q soil is the vapor entry rate, Q building is the building ventilation rate. And so this ratio essentially equals the subslab to indoor air attenuation factor. And so you can either put in the screening attenuation factor of 0.03 or a justified value that's based on multiple lines of evidence specifically about that building. And next in the model, you're going to want to put in your site-specific subsurface condition values so that the model can account for any and predict the attenuation from the soil gas to subslab. Ultimately, as much as you can, you're going to want to use sampling data to verify the model's predictions as appropriate. Once the risk has been assessed, now the VI risk needs to be managed. So the guidance provides considerations for the following 6 risk management options. For a given site, you'll most likely be using more than one of these options to manage the risk at all of the potentially impacted buildings at the site. So on the next few slides, I'll go over each of these risk management options. So the first risk management option is to designate a building as low priority for VI risk. So I'm going to go through some of the considerations for making that decision. First, let's look at the 2 different types of low priority buildings. First, you could have a building where indoor air demonstrates there's a low current VI risk, whereas the subsurface data shows there's a potential future VI risk. So for that building, you'd have no action for current VI risk unless conditions changed at the building. And then you would also be selecting a different risk management option to address that future risk. The second type is basically where we have low risk for both current and future VI risk. And so in that case, you'd have no action to address either current or future risk unless conditions change. And so when we have these low priority buildings, we're definitely going to want to make sure we're monitoring for changes in conditions throughout the cleanup process. So some of the ways you can do this are using building surveys to identify changes that could increase VI risk at the buildings. So this could be, remodeling that happens or changes in HVAC system. You're also going to want to use site-wide soil gas monitoring data, and you can use this to reassess the risk when site conditions change. So if that site-wide soil gas data indicates that the contamination is migrating towards that low priority building, you're either going to want to collect soil gas sample close to the building or just go directly to indoor air and get the data to reassess that VI risk for the building. However, you might find over time that the site-wide soil gas monitoring shows that there's no future migration of that contamination towards the building. And so in that case, you would decide that there's no further reassessment of VI risk at that building, and you'd want to have that determination for all the buildings before you get closure for the site. Okay, now I'm going to go over some considerations for the monitoring only response action. And so this could be monitoring of indoor air for assessing current risk and subslab and or soil gas sampling at the building for assessing future risk. So in general, we're going to use monitoring to reduce the exposure uncertainties, as well as potentially to justify the protectiveness of the selected potential future attenuation factors for that building. In general, you're only going to want to use the monitoring only response action if the other risk management options are not warranted and or feasible. So when selecting the monitoring frequency, we want to consider the potential changes that could increase VI risk. So we're capturing that in our monitoring. So first, you want to think about the seasonal temperature and barometric pressure changes that are expected in the area of your building. You want to think about how often is that water table fluctuating? Are there going to be changes in the soil moisture around the building? Are there going to be modifications to the building or the ventilation system and or the HVAC system? And then also, is groundwater or soil gas plume migrating and or is it stable? Okay, now let's go over some considerations for VI mitigation. So if you have an existing building where there is a current indoor air exposure, you're definitely going to want to use whatever feasible mitigation options you have to reduce that indoor air exposure. At a potential future building, you're going to want to use multiple lines of evidence to make a site-specific decision about whether or not to install a VI mitigation system at that future building. You're going to want to be able to tailor the mitigation approach based on the level of expected exposure. So this could be based on the nature of the contaminant, the magnitude of the contamination, and also the duration of expected exposure for those building occupants. You're also going to want to be able to adjust the mitigation approach as needed. There could be times where you try a certain approach and it doesn't work, and you need to make iterative changes until you get sufficient reduction in exposure. And lastly, just remember, mitigation should not be seen as a substitute for remediation. Okay, here are the interim remedial action considerations. So we can use interim remedial action to address current risk and expedite the reduction of high indoor air exposures. And so some examples of how we can do this to address VI risk: we could do some excavation of a release area to reduce contamination. We could also do soil vapor extraction near or below a building. We could also use groundwater pumping to restrict the plume migration below down gradient buildings. Okay, here are the remedial action considerations. So in general, we want to implement timely cleanup to reduce mitigation and or mitigation timeframes. We also want to make remedial action decisions based on the results of site-wide investigation, including characterization of the risk and the technologies available to achieve the site-based cleanup goals. We want to select remedial action objectives or cleanup goals based on site-specific information, such as the justified building-specific attenuation factor, as we discussed previously. Okay, lastly, let's go over the considerations for institutional controls used as the risk management option to address either current or future VI risk. So in the case of current VI risk, institutional controls can be used when mitigation is not effective or feasible at addressing a current indoor air exposure. In the case of future VI risk, institutional controls can be used when remedial action objectives are not protective of all reasonably foreseeable future uses of the property. So some examples for institutional controls that address current VI risk: we can have temporary building use changes to reduce the occupancy time at the building. We can also do relocation of building occupants. Typically, this is only done if there's an acute or short-term exposure scenario. And just keep in mind that a site-specific risk assessment will be needed to justify the protectiveness of building use changes implemented using institutional controls. And some examples for future VI risk: so we can use land use covenants restricting building or land uses. So for example, we can restrict residential or school use at the property. We can limit building occupancy or potentially prohibit activities that are inconsistent with a site-specific risk management plan for the site. Okay, in conclusion, we've gone over how to use step 4 to evaluate and manage the VI risk at every building near site contamination.